Memcached is a very fast in-memory cache. It was built by a company called Jenga to power a website called LiveJournal. And before Facebook took over the world, LiveJournal was a very popular site where people had their own blogs, kind of like Tumblr or Blogspot. I don't know, a bunch of things that have risen to take the place of LiveJournal. But LiveJournal was a very popular site back in the day. And when I say back in the day, I mean 2003 is when Memcached was released. Now, just about every website on the internet uses Memcached these days. I don't know about Google, but certainly it's used by Facebook, it's used by Reddit, it's used by YouTube, Twitter. It is an essential piece of software when you're writing web applications. And in fact, other than Linux itself, Memcached is probably the piece of software that's most in common between every website online. It's pretty astounding. It's very, very simple, and it's very, very effective at what it does. Okay, so to draw a bigger version of that picture I did on the quiz, how Memcached fits in, it looks something like this. Memcached is a process. Often you run it on its own machine, but you can also run it on the machines with your app servers. And it's a very simple system. The algorithm doesn't change. A request comes in, we check Memcached. If our response is there, we send it back to the user. If it isn't there, we check our database instead and write to Memcached. As we've been doing, the algorithm should be pretty familiar to you by now. What's handy about it is all of these app servers can interact with Memcached. Memcached is fast enough and can support many, many sockets that it works very well in this scenario. Also, most Memcached libraries have built into it this notion of having multiple Memcached machines. Because Memcached is just a key value store, it's like basically a giant hash table, you can hash on the keys to decide which server to send your data to. And because it's a cache, it's okay if you lose data from time to time, because you'll get the authoritative copy out of the database. And this distribution of keys over multiple servers is generally handled by the library. Sometimes you have to do it yourself, but most libraries in the Python library we'll be using in this class just abstracts all of this for you, so you don't have to deal with it. It's very common to actually run a little Memcached server on each machine, and then have each app server communicate to all of the caches, and you kind of get this big ball of connections. But everything works out okay. So Memcached is a very simple protocol, and the operations it does are very simple. So ultimately, we're going to be storing keys to values, where the keys and values are both strings. And the operations look something like this. We've got set, and this takes a key and a value. We've got get, this takes a key and returns a value. And we've got delete, which takes a key and deletes the key. There are other operations, and there are actually a few other parameters here. But these are the basic ones. And you can see with these three main operations, set, get, and delete, we could actually implement all of the caching we've been doing in ASCII-Chan in a system that will scale a lot better than having just a dictionary in our process. It also means that if the advantage we get from using Memcached is if our process restarts, we don't have an empty dictionary anymore. We have our Memcached, and our content lives on. So what I'd like you to do first is implement a fake version of Memcached.